This video is on finding the position to term rule. This is also known as the nth term of a sequence. So what I have here are three sequences. I've called them sequence 1, 2 and 3. And here I have the position of the terms that I have in my sequence. So all the first terms are here, all the second terms are here, and the third terms are here, and so on. I also have this, the nth term. Now this n is going to be here as a variable. This can, this n can stand for an 11, 23, a 54, a 100th term. It can be all of those numbers. It's a variable here. So that's how we're going to use that n there. Now, one thing you can notice about my sequences is that to go from one term to the next, it's always adding 3. So that's for all of my sequences. Now, if I look at sequence 1, I can see that this is going to be add 3 to get to 5. And from 5 to 8, I need to add 3 again. And from 8 to 11, I need to add 3. This is a common difference that I have. And it's add 3. I can show that with an arrow like that. Now, because it's add 3 all the way through, this is what you call a linear sequence. So this is a linear sequence because there's a common difference, and that common difference is adding 3. All of my sequences are linear sequences because you can see that they all have a common difference, and they actually have the same common difference, which is to add on 3 each time. Now I'm going to start with this sequence here at the bottom. Now this sequence here, you will notice it as the 3 times table. So the first term of the sequence is 3, the second term is 6, the third term is 9, and the fourth is 12, and the fifth is 15. Now what if I wanted to know the 11th term? How can I get that? Now, because we know that this is our 3 times table, I can tell you that it will be 3 times 11. If I wanted to know the 15th term, I'll do 3 times 15. Now, we want to write a rule in algebra to show this. Now, what we're going to do is we're going to say that this is going to be 3n for us. Now, remember, this n stands here as a variable. Now, this could be 2, this could be 3. So if I use 2 here, I'm looking for the second term. So if I do 3n, that means 3 times n. So 3 times 2 would give me 6, and that gives me this one here. Let's try for the fourth one. So this time we would do 3 times 4. So 3 times 4 to get this, and it's 12. And I can see that this is correct. So my nth term, or the position to term rule, is 3n. Now, there's a reason why I did this one first. This is the easiest one to do out of these. But then there's another reason why I put this here, and that is because this sequence is very similar to the ones above it, because the common difference is plus 3. So I can see that this is plus 3, this is plus 3. Same here. 7 to 10, I need to add 3. 10 to 13, I need to add 3. 13 to 16, I need to add 3. So let's look at how those ones will compare. Now, to find the nth term of this one, well, I know something about it already. I know that it goes up in 3s. So if it goes up in 3s, this will help me, because I'll show you how this will help me. If I'm looking for the first term, I will do 3 times 1, and then I might need to do something else. If I'm looking for the second term, I will do 3 times 2. Now the reason why this helps me, let me just write another one. If I write 3 times 3 here. So the reason why this will help me with this sequence is because, can you see how this to that is going up in 3s? Now that's a thing that we have here as well. We see that is common here. So this is going up in 3s. That's also going up in 3s. But 3 times 1 won't give me 2. So that's where we have a problem. 3 times 2 won't give me 5. And 3 times 3 won't give me 8. Now, how can I use 3 times 1 and still get to 2? Well, I can take away 1. 3 times 1 is 3. And if I take away 1, I'll do this in a different color. So if I take away 1 after that, that will actually give me 2. Let me see if that works for the other ones. So 3 times 2 is 6. Take away 1. Does that give me 5? Yes, it does. And let's see if it works for this one as well. 3 times 3 is 9. If I take away 1, it does actually give me 8. So if I do 3 times the position number, which is 1 here, 2 here, the 3 there. So 3 times 1, 3 times 2, 3 times 3. And then if I take away 1, I always get the value of the value of the different terms in my sequences. So here I can see that my rule is going to be multiply the position number. So multiply the position number by 3 and then subtract 1. So it'll be 3 times 1, which is 3, take away 1 is 2. Let's try it for the fifth one. So 3 times 5 is 15, take away 1 will give me 14. So it works. Now how would I write this in algebra? So this, in algebra, it would look like this. We've got 3 times the position number, so that's similar to this one. So 3 times the position number, I can see that here, 3 times the position number, and then I need to subtract 1 as well, and that will give me my nth term. So if I want to find the nth terms, for example, the 10th term, so the 10th term would be 3 times 10, which is 30, take away 1, which is 29. And that would be right. If I was to carry on this sequence, you will find that the 10th term is 29. Now, you should be able to work out what the nth term of this middle sequence is, because it's very similar. You can see that the common difference, again, is add 3. And then I can see here, we got add 3. Remember, these are linear sequences we have here. So it's going to be a common difference that we find, which is add 3. So again, so it's a little bit like this 3 times table, because the 3 times table, it goes up in 3s. So I can start by writing 3 times 1 for the first one, 3 times 2, 3 times 3, 3 times 4, and then see how I can change that to find 7 for the first position, to find 10 for the second position, and so on. So let's try that. So what we have now is, okay, we want to do 3 times 1, and then 3 times 2, and then 3 times 3, and then see how I can use this to get to 7. And remember, the reason why we're doing this is because this is going to be 3, this is going to be 6, this is going to be 9, and I'm going to have a common difference of 3. So 3 times 1 is 3. Now how do I get to 7 from that? I need to add 4. Okay, so let's try that. So let me write that here. So add 4. So 3 times 1 is 3, add 4 is 7. Okay, let's see if that same thing works here. 3 times 2 is 6. If I add 4, I do get 10. And then I have 3 times 3, which is 9. If I add 4, I will get 11. So what I should have is add 4 each time. So I multiply the position, so the position number by 3. So the position number here is 1. So I multiply that by 3, and then I add 4. The position number here is 2, so I multiply the 2 by 3, and then add 4, and then so on. So you can see that the rule is actually to multiply by 3. So to multiply by 3, so multiply the position number by 3, and then add 4. Now let's quickly check if it works for the fifth one. So I need to multiply this position number, which is 5. So 5 times 3 I need to do. So 5 times 3 is 15. And then I need to add 4. So 15 add 4. Does it give me 19? It does give me 19. So this actually does work for us. So let's write it here. So I need to do 3 times the position number. And remember, this n here stands for our position number. And then I need to add 4 to that. Now let's see what the 10th term would be. So for the 10th term would be, so 10 here, 10 goes there, and we do 3 times 10, which is 30. And then if I add 4 to that, I'll get 34. Now you can continue this sequence all the way up to the 10th term and check if it's 34. And you will find that it is. Now I have some questions for you to do. So I want you to do these questions and then bring this to the lesson. So the first task you have here is to find the nth term. Remember, this is also called the position to term rule of the sequences below. Now these sequences are all linear sequences, but the common difference might not be 3. It might be something else. So you need to find that nth term that I wrote for all of these sequences. And then I want you to do question 4, which is the sequences in question 2 and question 3 have a special relationship. I want you to investigate this and write down what it is using examples. So write down what the special relationship is and use some examples to show exactly what you mean. And then question 5, I want you to write down a sequence that has a special relationship with the sequence in question 1. So maybe you're going to find something about these two sequences, and I want you to write a new sequence that will have a special relationship with the sequence in question 1. and I also want you to find its nth term. So do all of these questions and then bring that to the lesson.